The lower handle surface is also a boundary, utilizing this pre-existing edge, an edge copied from the front layout, and utilizing the same tilted plane that was used for the profile of the bottom of the outside of the handle. Another profile is drawn to define the shape of the handle down in this area. We use continuous curvature in this area if we can apply it. If not, we'll use tangency. And again, what we've done is we purposely made sure that this handle is passing completely through the right-hand surface. Now, up to this point, we've built a total of 6 surfaces, none of which have been knit together. These two meet along this line and have curvature continuous here. These two meet along this line, also have curvature continuous. Everything else meets on a sharp edge and is not blended together, as you can see with the zebra stripes. Here they're smooth, here they're smooth, here there's an abrupt edge, here there's an abrupt edge, which is intentional. We're just about ready to tackle this difficult filleting situation. In order to do this, we have to do our steps in a very particular order, so we have to pay careful attention to that. What we're going to do is create situations that are easy for Solidworks to fillet. Solidworks has no trouble filleting a single edge as long as it does not run into a series of other edges. So we're going to try to create that situation wherever possible. The first thing we're going to do is just knit together these two pieces of the handle, but not knit them to anything else. We can now add a fillet to this edge. And we see this was easily filleted right up to the edge because it doesn't have to worry about these other surfaces because it is not yet knit to these surfaces. This is just a typical fillet, nothing special. This fillet runs down to the bottom, passes through the right-hand surface. At this point, we can go ahead and do a mutual trim between the handle and the right surface to get rid of all this excess material. That leaves a hole where the handle joins the surface of the right surface and an edge, which we can then fillet. There's more graceful ways of doing this, but I'm being lazy now and we'll live with that. At this point now, I will go ahead and knit this surface, and this surface together, leaving us with two main surface bodies that have not yet been knit together. Now we want to create another situation which is easy for Solidworks to fillet. What we're going to do, instead of trying to fillet this edge, is we're going to just hack this entire edge out with a trim, leaving a gap all the way along this length. And finally go ahead and knit all the surfaces together into a single surface. And what we've done is created a situation now where these edges are ending on a free edge. This is a much easier edge to fillet now because it's not running into another edge. So I'll go ahead and fillet that. Again, that's just a conventional fillet, nothing special, with a very simple situation. For now, I'll leave this edge sharp. The next step is to create a virtual fillet in here just by creating a boundary surface. To do that, I need to select this as a direction 1 curve, and then I need to piece together this edge using my selection manager to piece together 1, 2, 3, 4 little pieces for my other direction 1 curve, and then direction 2 will be this little piece here and a sketch that I need to draw on my front plane here. Everything will be set to tangency along the edges. When done, we